All right, hello. This is the key for the 4.7 to 4.9 quiz. All right, so question number one, we have these two solutions right here, and it says that we're going to mix those two together, and when the solutions combine, a precipitation reaction took place. So which of the diagrams below is the best particle representation of the mixtures after the precipitation reaction occurs? Okay, so with a precipitation reaction, there's going to be a solid that forms. It's going to be an ionic solid. So we want to have a positive and negative ion together, and that should be at the bottom of the container. And then the other ions will stay in solution. So we want to show that the other ions are separated. Okay, now for the identity of the precipitate, you want to remember the solubility rules. Sodium and nitrate are always soluble ions. So they are not going to be part of the precipitate, and they want to be shown as being separate ions, not connected to each other. So the precipitate has to be silver ions and chloride ions. So we want those together at the bottom of the container. So the answer, the only one that shows that situation, is letter D. Silver chloride together as a solid, and then the sodium and nitrate as an ionic substance being separated. Okay. All right. Question number two. All right. So we have this balanced equation right here. Okay. So this first couple sentences here really doesn't apply to the question that's being asked here. It says which element is being oxidized during the titration, and what is the element's change in oxidation number? Okay. So we want to go through and assign oxidation numbers for all these. Okay, now this one's a tough one because of this H2O2 right here. Okay, this is a situation that comes up just once in a while. This H2O2 is hydrogen peroxide, and in peroxides, oxygen has a -1 oxidation state, or -1 oxidation number. Okay, so this oxygen right here is going from -1 over to 0 on the product side. So it's going to be letter A, oxygen with changes from -1 to 0. Question 3, which of the following represents a process in which a species is reduced? So with this, we want to look at oxidation numbers and look for a decrease. The only one that's showing that is letter D. It's not the oxygen, it's the nitrogen. Nitrogen goes from a +5 to a +2, so it's showing a decrease in oxidation number, so it is reduced. Question 4. Okay, so we have all these compounds right here. It says, which of the following compounds at 25 degrees Celsius in 1 atmosphere contain an element in a +1 oxidation state? Well, first of all, the temperature and pressure have nothing to do with it. We just want to look for these chemical formulas and see where do we have a +1. And the only situation where that happens is a Cu2O. Oxygen's a -2, so the copper has to be +1 to get those oxidation states to add up to 0. These are all neutral compounds, so the oxidation states have to add up to 0. So it's letter E. Okay, so now we have these 5 reactions right here. Okay, and the question here is we're looking for a precipitation reaction. Okay, so you want to know the properties of a precipitation reaction. That's where we go from two things that are aqueous to a solid. Okay, so we have to have a solid product, and the only one of these 5 that shows a solid product is this one right here. So we go aqueous, aqueous to solid. That's what a precipitation reaction is. So it's going to be letter D. Okay, question 6. With the same reactions, or no, it's not the same reactions, I'm sorry, but another set of 5 reactions. And this one, we want to show a Bronsted-Lowry acid and a Bronsted-Lowry base. So it's an acid-base reaction that we're looking for. So with an acid-base reaction, that's defined by a transfer of a proton or transfer of a hydrogen ion. So you want to look for a reaction where we're seeing a hydrogen ion, transferred from one reactant to the other. And that's this one right here, where the hydrogen ion, if you compare the reactants to the products, there's a hydrogen ion transferred from this H3O plus to this to the C2H3O2 ion. So that's the acid-base reaction, so it's going to be letter B. Question 7, which of the following is the conjugate acid of NH2 negative? Okay, so we're looking for the conjugate acid. That's saying that this is the base right here. Okay, so a base is defined as a hydrogen ion or proton acceptor. So we just need to add, to figure out the conjugate acid, we need to add a hydrogen ion to this. So the number of H's will go up by 1 and the charge will go up by 1. So it goes from -1 to being neutral. So it's NH3 with a neutral charge, letter B. Okay, question 8. Which of the following is the balanced net ionic equation for the oxidation reduction reaction between silver and nickel based on the half reactions present above? Okay, so this is part of the half reaction balancing process. Okay, so we have these two halves right here. You have to, the part that they're asking you about is you have to understand the concept that the electrons have to cancel out. So we have to multiply this bottom half right here by an integer of 2 to get 2 electrons on the left, which cancel out the 2 electrons on the right. That means when you put them together, the silver ion and the silver solid will both have coefficients of 2. So the answer then has to be D. D is the only one that shows coefficients of 2 for both of those. Okay, and that's all for that quiz.